All right. Welcome back. Another lesson. This is our final lesson in this triangle unit. We're going to talk about isosceles and equilateral triangles today, okay? Ta-da! There's the title. Okay? So just make sure you have your notebook ready and let's get started. All right? So, first thing, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of those sides are congruent. Probably thinking, wait a minute, Mr. McCullough, I know isosceles triangles have two congruent sides. And I'll be saying, yes, you should know. But here's the additional part of it. Look at this picture, okay? If I go diagonally across both of these sides that are congruent, the opposite angles are also congruent, okay? So for instance, if this is 30 degrees, this guy would be 30 degrees as well, okay? That's a new piece of information that you didn't know before. So now the base angles are also congruent, okay? Now, conversely, we can also say if these two base angles, or opposite angles, are congruent, then if we go diagonally across each angle, these sides can be congruent. Remember, the converse just means take my theorem, flip the first and the last part, and it still holds true. Okay? So the question down here is, angles 5 and 6 are congruent. What sides are congruent? That would be AC and BC. Those would be the congruent sides. Okay? That's the first part of this lesson. All right? It's just knowing that the base angles are congruent. So, what we're going to do, we're going to ignore that. And we're going to look at this. Okay, we're going to do it on the board here. All right, so we'll just exit out of that just real quick. There we go. Okay, so taking a look at this picture first. We're going to identify two sides that are congruent and two angles that are congruent. So there's 4 parts here. I'm going to mark it on the picture up here. So let's take a look. So I have these two base angles, right? Now, what sides are congruent because of it? So just go diagonally across. So we're at this angle. If we go in this direction, I could say that this side, okay, will be congruent to this side. Now, you see how this one already has a congruent mark? So just to make sure I don't confuse things, maybe you should put 2 marks there, right? We'll do something like that. Okay? So that means that AD is congruent to AC. So that's the new thing I'm adding to the picture. Now, let's look at this guy over here. Okay? If I go diagonally across from the two congruent sides, I could say that angle B and angle C, but those two are going to be congruent. Okay? Now, we can name these. Let's see. The first one we can name is ABC is congruent to angle ACB. Okay? So there's the 2 parts that we can mark congruent based on the information. Let's try another one. Okay? Let's look at this example here. Let's try and mark what's congruent in the picture. Now, let's look at the angles. So once again, we have 2 angles here, and notice something. There's a lot of triangles going on. Focus on one triangle at a time. So if I look at the largest triangle right here, ignore this line. Pretend that this line doesn't exist. If I go diagonally across, I could see that GH is congruent to JH. Okay, that's the isosceles, the converse of the isosceles triangle theorem. Okay, so there's the 2 that are not marked. So GH is congruent to JH. Okay. Now let's look at the these guys over here. Once again, just ignore FH. Pretend that this line doesn't exist for right now. If I go diagonally across from each of these congruent sides, I can see that those angles right there are congruent. So that would be angle FJ. Did I? No, I was good. Okay, so FJG would be congruent to angle FGJ. So that's these guys right here. Okay? Now, do you have to, when you're working on this, do you have to draw those dotted diagonals? No, but I think it does help just to locate it, especially when you have a picture that has more than one triangle involved. Okay? Now, some people might say, okay, well, Mr. McCullough, why did you ignore line FH for that to work? It's a great question. I'm glad you asked it. The reason why I was ignoring this is because look at this guy. These two angles are part of the whole triangle JGH, right? Okay. So I'm looking at the entire triangle and what those two angles are part of. If I included this line, then this angle has nothing else to partner with, right? And this solid triangle right here. Same thing with this. If I look at these two side lengths, they're part of the triangle FGJ. So I want to make sure that when I'm marking the angles, I'm marking angles that are in that entire triangle. If I include this line FH, I have nothing to mark then because I'm dividing that triangle. Okay, so it's not like I'm saying ignore that. If you ignore it, it works. No, there's a reason why. And let's go to the next one. Sorry. Okay, back to the PowerPoint. There. So that's isosceles triangles. Let's look at equilateral. Now, we know that an equilateral triangle, all the sides are congruent. But did you also know that if it's an equilateral, it's also equiangular? So that means all my angles are the same measurement. They're always going to be 60 though. There's 180 degrees in a triangle, right? And if all of these angles are congruent, then it would be what? 3 into 180, which gives you 60, since they all are the same. So anytime you see 60 degrees, you can assume that all the side lengths are congruent then, okay? So that's what the equilateral triangle corollaries we're talking about here. Any questions? It's kind of weird, right? It's pretty much, you know what these triangles are by their side lengths. This lesson's introducing their angle measurements, which is really cool, something that we can use for future measurements. Speaking of which, boom. Okay, so go ahead and write these down. And what we're going to do is we're going to solve these together, okay? And maybe I can zoom in a little bit. That way it's a little bit easier. There we go. Okay. So this is example 1 up here. This is example 2, and this guy's example 3. Okay, so let's look at example 1 here. We're trying to find the measurement of angle y, and we're trying to find the measurement of yz. Okay, and actually, let me just make one little adjustment. I just noticed something. This should be 60 degrees. There we go. Okay, I apologize for that. Didn't mean to forget that measurement. Okay, here's what I would do first. Notice that these two sides are both 8 inches. So because of that, I'm going to go ahead and mark those sides congruent. Okay? Now, if I go diagonally across, I know that these two angles are going to be the same measurement. We talked about that before. That's the isosceles triangle theorem. Now this is pretty interesting. Watch this. If this is 60, these two angles are the same, and they all add up to 180 degrees. So let's eliminate something here. 180 minus 60 is 120. These two both add up to be 120 degrees, and they're the same measurement. So if I just do a little division, divide both by 2, I could say that each of those angles are 60 degrees. Now, why is that important? Well, for one, the measurement of angle y, we know what that is. That's going to be 60 degrees. But think about this. YZ, that's this guy right here. How long is that side? Well, 60, 60, and 60. That's an equiangular triangle. And we just said it in the previous slide. If all the angles are congruent, all the sides are congruent. So that means this is also the same as the other two sides. So it must be 8 inches. Okay? Problem's done. Let's try the next one over here. Okay? So for this example, we got to figure out the measurement of M and the length of PN. Okay. I'm going to go after the angles first. Now notice, this is 120 degrees. These two angles are congruent, and we know that because of these arcs here. Okay? So 180, because there's 180 degrees in a triangle, 180 minus 120 gives me 60. If both of these angles add up to 60 and they're the same, how do we find it? Well, just divide by 2 again, right? So that means each angle is going to be 30 degrees. Okay? You can always check your work, right? 30 plus 30 is 60, plus 120 gives me 180. We're good. So the measurement of M is going to be 30 degrees there. Okay? All right, now the measurement of PN. Okay, what's that going to be? Well, first things first, just like the previous problem, I apologize. This side's 11 centimeters. I forgot to mark that in. You really can't figure it out without that measurement. Now, if these guys are congruent, if I go diagonally across from them, then these side lengths are congruent. Okay, that's the converse of the isosceles triangle theorem. So if this is 11 centimeters, then this guy must be 11 centimeters. So there we go. And we're done. Okay, what's a good strategy for this? Well, it just depends on the information they give you. If they give you angle measurements, go off the angle measurements. If they give you the side lengths, go off the side lengths. Okay? Using the proper theorem or corollary, you can figure out the rest of the measurements. Okay, grand finale. So here's the last problem that we're going to try out. Okay, right here. So, looking at this picture here, I can see that these two side lengths are congruent because of those symbols. So if that's the case, then I could say 4y minus 2 equals 2y plus 2. Okay? Now there's nothing new about that. We can figure that out without this lesson. Let's go ahead and solve it real quick. So we're going to subtract 2y to both sides. 2y minus 2 equals 2. Add 2. And ooh, you almost can see that. Let me just lower it a little bit. So we have 2y equals 4. And then my last step, divide both sides by 2. Y ends up being 2. Okay? We should check our work. If these are congruent, they should be the same answer. So let's plug 2 in. 4 times 2 is 8, minus 2 is 6. 2 times 2 is 4, plus 2 gives me 6. All right, we did it correctly. So we're good. Now look at x for a second. Okay, this might be a little tricky at first. Here's what I would do. If I go across diagonally from each congruent side, I know that those angles have to be the same measurement, right? Now, if this angle is 80 degrees, if I subtract it from 180, I get 100. That means these two angles add up to be 100 degrees, and they got to be the same. So that means this angle must be 50 degrees, and this angle must be 50 degrees. Okay? Just like the previous problem up here on how we figured that out. Now, 6x plus 8 represents this whole angle. So if I want to figure out what x is, I got to set this equal to 50 degrees, because that's what the angle is. So 6x plus 8 equals 50. Subtract 8 from both sides. 6x equals 42. And my last step, divide both sides by 6. So x ends up being 7 for that guy. Okay? Now, you could, or, I'll put an or case there. Is there another way to solve for x besides what I did here? Absolutely. For instance, if this guy is 6x plus 8, this guy is 6x plus 8, right? So then I can add all three of these and set them equal to 180. So what you could do is you could say 80 plus 6x plus 8 plus 6x plus 8 equals 180. Okay? Now, if I solve this for x, am I still going to get 7? Absolutely. you're still going to get the same response. You're still going to get the same answer. In fact, why don't we just do it? So these 6x's will give me 12. 8 and 8 gives me 16, plus 80 gives me 96, equals 180. Subtract 96 from both sides. 12x equals 84. Divide both sides by 12. X ends up becoming 7 still. So as you can see, you still get the same response. Okay? So pretty much, because these are the same, 6x plus 8 can also be over here, which is 6x plus 8. So you can come up with a different equation, set them equal to 180, because that's how many degrees are in a triangle. Okay? Now, do you have to do that? No. I think by setting each one equal to 50 degrees, we made the calculation a little bit less. Okay? The numbers weren't as high, but still not as, it's not like there's a difficulty spike here. Okay, so you still have more than one way to reach that answer. All right, that's it, guys. That's isosceles and equilateral triangles. Okay, so stay tuned for some practice work with it. If you have any questions, let me know. And hey, until next time, guys, I'll see you guys in the next lesson video. Take care.